Alright guys, welcome back. 3.2, solving linear equations. Today we've got two things on the agenda. We're going to solve linear equations by graphing, and we're also going to use algebra. And then we're also going to estimate solutions to linear equations by graphing. So we have two things that are involving graphing today, but I also am going to show you how to solve linear equations algebraically. So that should actually be the third thing that we have on our agenda. Okay, so let's get into linear functions. We studied last time what a linear function is. It's a function for which the graph is a line. Okay, the simplest one is f of x equals x. Remember, don't get confused here, you guys. F of x is just another way of saying y, right? It's just saying the function evaluated at x. And when functions are evaluated at x, when you plug an x into a typical function, you're going to get a y value out. So this is just another way of saying y equals x, but they want you to get used to that new notation, function notation, because we use it a lot later in later maths. So you'll see a little bit of that plugged in here, but y equals x. All right, you can graph that on Desmos, and you can manipulate it, morph it, and see what happens if you add something to that, or if you put something out front, or if you put a negative in there. I encourage you to do that, but y equals x simply just looks like this, and that's going through the middle there. It's just a graph that has a slope of 1 and goes through 0, 0. All right, so that's the easiest graph that we could, it's called the parent function, or it's the easiest line that we can graph. From there, we can manipulate it just by adding things to it, subtracting things from it. And what this means, y equals x, is just so that people get the visual, is if you plug a 1 in for x, you're going to get a 1 out for y. Okay, so this line, no matter where you are, if you plug in a million, right, if you plugged in a million in for x, then if that's a million, on the y, you would also be at a million. So it's the place where the x and the y is the same, right, on the y equals x. If we don't want y and x to be the same, then we have to change something about the parent function. So we have to manipulate it, right? So if you did y equals 2x plus 3, then every time we put an x value in, right, let's just try it here. If we plugged a 1 in for x into this equation, notice then you would have 1 times 2 is 2, 2 plus 3 is 5. So you'd have y equals 5 when you plug a 1 into this equation. Whereas here, it was just a 1-to-1. All right, so it will look different when you manipulate the parent function. Anyway, we'll get more into that later. The solutions, so today, you're going to have a couple new, they're probably not new terms, but I'm just going to show you how these terms connect. The terms are solutions, roots, x-intercepts, which I'll just abbreviate, and zeros. All three of these things, you guys, when it comes to lines, they all mean the same thing. What they're trying to get you to see is that when we're graphing lines, okay, so just put a picture of a line here. The solution to just a standard straight line, when you're graphing it, is always going to happen right here, right where, maybe I'll do that in blue, right here, right where the graph crosses the x-intercept. Okay, the solution to a linear problem is where the graph intersects the x-axis. That is the solution. We also call it a root. We also call it an x-intercept. We also call it a zero. So don't get confused. They're all talking about the same place on the graph. All right, so the root, again, is the solution of an equation, what makes the equation true, and it's found by replacing y or f of x with 0. Which makes sense, right? Because what is the y value always when we have an x-intercept? Notice that on the y, we are always going to be at 0. Right? When y is 0 is where we have this intercept here. It's always going to occur when y is 0. So we replace y or f of x with 0, and then we solve it. Okay, so the zeros are the values of x for which f of x equals 0. Plug a 0 in for f of x or for y, which is what I did there, right? And then we solve it. So we add 6 to both sides, right? And we end up getting 6 equals 2x, and then we divide both sides by 2 to get the x by itself. and we have x equals 3. That 3 is the intercept, it's the solution, it's the root, it's the 0. All right. So moving on to graphing these things now. So graphing linear functions. A couple of steps for graphing. It's kind of weird that I'm teaching you graphing here, that we're going to solve the next one algebraically, but we are going to get into graphing here in just a little bit, so we'll refer back to this. But essentially, we're going to just plug in a 0 for the x value to see where the graph crosses y, right? And then we can make a chart. We can also plug in, as a side note, you can also plug a 0 in for y on an xy table. If you plug a 0 in for y, which is kind of what we're doing algebraically today, we can see what the x-intercept is, which is where the solution is, right? So that's important too. So step 2, we make a chart, plug in a few x values to find the y's. I said usually 1, 2, and 3 works. We'll see later on that if we have fractions, other numbers work better, but you can also use like -1, 0, 1. We just need to get a couple points in order to figure out what that line's doing. And then step 3, we're going to use the chart to graph the line. Okay. So we're going to come back to this because this is the steps to graphing. What I want to show you now is how to solve things algebraically. All right, so originally in your textbook, you'll either have a y equals or an f of x equals something. So this one started like this, y equals 2/5 x plus 6. Your job today is going to be to replace that y with a 0 because we're trying to find the place where y is 0. That's really the goal. So I've replaced it with 0. Now I'm going to solve it. Okay, so to solve this, I'm trying to get this guy by itself. All right, we're just going back to basic rules of algebra. So to do that, I'm going to get rid of this guy. So I subtract 6 from both sides. So I get -6 is equal to 2/5 x. And then I got to get x by itself. Right now, this is being multiplied, right? So I need to divide by 2/5. But remember, dividing by 2/5, you're dividing by a fraction, is the same thing as flipping the fraction and multiplying. So I can take this fraction and multiply it by 5/2, and I'd be left with 1, right, which is what I want. So I'm going to multiply both sides by 5/2. Okay, I'm multiplying both sides. That makes this go away, which is my goal. And that makes this go to, well, 5/2 times -6/1 equals -30/2, which is equal to -15. So x is equal to -15. So to solve this algebraically, I found that x is equal to -15. That is the place where the graph crosses the x-axis. And we'll prove that in the next little lesson, or the next little slide. Next here, let's do this one. So we have -1.25x plus 3 equals 0. I want this by itself, so I'm going to subtract 3 from both sides. So I get -1.25x is equal to -3. Divide both sides by -1.25 to get that x by itself. Okay, when you do that out on your calculator, you should be getting x is equal to, this is a negative, negative divided by negative is positive 2.4. Okay, those are the solutions. So this one, it crosses the x at 2.4, so somewhere in here. And then I know the intercept is at 3, so it's some kind of line that goes like this. And we're going to look at that next time here. So notice, you guys, I've already done this ahead of time just to save a little bit of time. You can plug whatever you want in for x. I'm choosing, in this particular case, 0, 5, and -5. The reason is I know that if I multiply 2/5, because I'm plugging these things in for x, right? If I multiply 2/5 by 5, I'm going to get a nice number. And that will always work with a fraction. If you have some kind of fraction, multiply by the thing that's in the denominator, and you're going to get a nice whole number out. Okay, so let's do that. If I plug a 0 in first, 0 times 2/5 is 0, 0 plus 6 is 6. Right, so there's my y-intercept. Happens at 0, 6. Then I'm going to take a 5 and plug it in. 5 times 2/5 is the same thing as 10/5, which is 2, right? 2 plus 6 is 8. And then here I have -5 times 2, which is -10. -10 divided by 5 is -2. -2 plus 6 is 4. All right, so let's take a look at this picture. What do we have going on here? We have a 0, 6. 1, 2, 3, 4, 5, 6. We've got that guy. And then we've got a 5, 8. 1, 2, 3, 4, 5. Going over 5. Up 2 from where we were. Okay, we got that guy. And then at negative 5, 1, 2, 3, 4, 5. We're at, we're going to go down 2 from there. So we have a line that looks something like this. Okay, the problem with this, trying to solve this by graphing, we have to either keep going until we hit the y, right, which is somewhere back here, or we have to kind of estimate where that happens, or we use Desmos, I guess, and see where that happens, or a graphing calculator. But what I like to do is I like to just say, okay, what happens if I choose the y value of 0? Okay, which we did up here, right? That's what we did up here. If you choose the y value of 0 and you solve that for x, you end up getting what we did up here, negative 15. Okay, so to show you that again, 0 is equal to 2/5 x plus 6. I'm just going to solve for x. I'm going to move my 6 over. Okay, then I'm going to divide both sides by 2/5, which is the same as multiplying by 5 over 2, and I get x is equal to negative 15 like I did up here. Okay, so I know that the solution happens there. I could also just continue to use my slope to figure that out, but I like knowing exactly where it happens algebraically. So I wanted to show you that. Okay, so for this one, if I plug a 0 in for this one, I get 3, right? Because this just goes away. If I plug a 4 in, notice this is like $1.25, right? So 4 times $1.25 is going to give you $5. So that's like negative $5 plus $3. I like changing it to money when we're talking about decimals. So negative 5 plus 3 is going to give me negative 2, right? And then if you do a negative times a negative here, that's going to be a positive $5 plus 3, which would be 8. Okay, so if I plug this in on my graph, I have 0, 3, which is right here. Nope. 0, 3. And then 4, negative 2. 1, 2, 3, 4. 1, 2, and then negative 4, 8. Something like that. Okay, so at 4, negative 2, we're here. And then at negative 4, 8. Somewhere up in there. We have this line that goes like this. Okay, and we said that this thing has a solution of 2.4. You can see that my graph's not perfect here, but you can kind of tell that this thing has a good possibility of crossing at 2.4, but you really don't know until you plug a 0 in for y, right? Solve this for 0, and then see what happens here, which is what we did up here. 2.4 is what we got when we solved that for 0. That's how I know it crosses at 2.4. Okay, so you can figure it out, or you can estimate it by just having a more perfect graph, which I'll give you graphs on your homework so yours will be a little bit more accurate. Okay, so example 1b, and then we're going to go into 2 more examples and we're done. So this is an example of no solution. So watch what happens here, you guys. If we have something like this, if we try to get the variable by itself, right? If we try to like move this over, notice what happens. This goes away, and we're left with 3 is equal to negative 5. Whenever you get something like that, that's not a true statement, no solution. All right, so if you see that today in your homework, just be mindful that this could happen and there could be no solutions to some of these problems. Here, same kind of deal. If I add 3x to both sides, this goes away, and I'm left with 2 equals 6, which cannot happen, right? So no solution. All right, moving right along. So example 2. Chi, I guess it's Chi, I don't know. Anyway, has a 120 cubic foot tank of gas for a 6,000 foot dive. The equation y equals 1, so I like to write this down as I go. The first thing I feel like I might need this in the problem, so he's going 6,000 feet. And his equation is y equals 120 minus 2x. Well, that looks a little different than our standard form of a line, so I'm just going to change that a little bit by rearranging this. okay, which is totally legal to do, right? I'm just switching those around. It says this describes the amount of air in his tank after X minutes. Okay, so the X values in this equation here represents time in minutes, right? It's good to identify our variables. The Y values would have to be, because it says the equation describes the amount of air in his tank after X minutes. So the Y value has to be air in tank. Okay, so Y is representing the air, X is representing the minutes. It says find the zero and describe what it means in the context of the situation, and then identify the domain and the range. Okay, so what they want us to do is they want us to see where does this equation, where does this go to zero? Where does my air in my tank run out? That's what we're curious about, right? So if Y represents air in the tank and they want to know zero, they want to set Y to equal 0. Okay, and they want us to know, like, they want to know when does this thing run out. Do I need to know the 6,000 feet piece that I thought I might? I actually don't in this case. They just want me to solve the equation for the 0. So notice I'm not going to use this information, okay, because this information was used to get this equation. And maybe even not. Maybe it's just, it doesn't matter how deep you dive. The tank is just going to give me this result, right, no matter what. So anyway, back to this. If I solve this for X, I want to subtract 120 from both sides. I get negative 120 is equal to negative 2X. Therefore, X is equal to 60. All right, so now, just find the 0 and describe what it means. Well, what does it mean? It means that I have 60 minutes until my tank runs out. Right? I set my Y to equal 0. My tank will run out when Y is 0. Okay, and how long does it take for that to happen? 60. So I'm assuming that that's 60 minutes since my X is in minutes. Okay, so it's the 0 is X equals 60. And the context is you basically you have 60 minutes before running out of air. Right, that's the context. And then it says identify the domain and the range. So if we're graphing this, you guys, notice this is my y-intercept, 120. If I plug a 0 in for x, I get 120. Okay, so here's x, here's y. If I plug a 0 in for x on this axis, I'll be here. Right, I'll be right here. If I plug that 0 in for x, I'm at 120 on the y. Okay, so here's 120 dot. Okay, if I plug a 0 in for y, right, on this axis, I'm still going to be at that red dot, but now I'm looking on the x-axis, I will be at 60. So here's the idea. This line does not go on forever. It says to identify the domain and the range. Well, if the y value is air in the tank, I can't have negative air in the tank, right? And I can't have negative minutes. So the negative parts of the graph just don't apply. So to identify the domain and the range, what they are talking about there is they want you to say, okay, for the domain, the possible x values on this equation, the x values start at, on this, so we're looking at this axis, they start at 0 and they go to 60. So 0 is less than or greater than x, which is less than or greater than 60. This is a way of doing what we call set notation, where the x values, we show that the x values lie between 0 and 60, and could include 0 or 60. The range here is the y values. Okay, so the y values are here. It starts at 0, right? Okay, so for the y, we can't have less than 0 in our tank of air, right? So I'm gonna say it starts at 0, and then now we're in the y. Okay, so y has to be bigger than 0, but it has to also, there will never be more than 120. Okay, so there's my domain and my range that makes sense. Okay, next, and then we're done with this lesson. Example 3, it says the freshman class is doing a fundraiser. They paid $45 for cupcakes. They're reselling them for $1.50 each. And then they created this function, or maybe their teacher created this function that represents the profit y when they sell X cupcakes. So notice, you guys, this is the equation that would represent this problem. Okay, if you pay $45 for cupcakes, then your total money, right? Y is your total profit. Your total profit is going to equal $1.50 times how many cupcakes you sell minus the amount you paid for them. Okay, because that's not profit. What you paid for them is part of the cost. So we have to subtract that out, right? So let's just say that I sell 100 cupcakes. I want to know how much money I actually make if I do that. Well, I got to plug in 100 for X, right? X is the cupcakes, to see what the profit is. And I could do that, and if I did do that, I would get 150 minus 45. Okay, I just moved the decimal twice because I'm multiplying by 100 there, and then Y would be equal to $105. Right, so if we sell 100 cupcakes, and this is the scenario, then I would make $105 profit. Okay, so here it says find the zeros and describe what it means in this context. So what does it mean if I plug a 0 in for Y? 0 would mean I don't make any money, right? 0 is, the Y is referring to profit. So if I plug a 0 in for Y, that means this is the place where I don't make any money. Okay, but I also break even. Okay, so if I do that and I solve that, trying to get the X by itself, I get 1.50x, $1.50 times X equals 45. Divide both sides by 1.50, which is the same as 1.5. And then that gets rid of that, and I'm left with X is equal to, if we take 45 and divide it by, if we took 45 and divided it by 15, we would get 3. So if you take 45 and divide it by 1.5, you would get 30. Okay, so if you sell 30 cupcakes, you make $0. That's your break-even point. Okay, what happens if you plug a 0 in for X? Y is equal to 1.5 times 0 minus 45. Okay, this is essentially saying we didn't sell any cupcakes, right? X is representing cupcakes. So if we put a 0 in for X, what does Y equal? Y is equal to negative $45. So here's the deal. If we went and bought $45 worth of cupcakes and we don't sell any of them, we just lost $45, right? So that's what that means. When it says, what does it mean in the context of this scenario? It means if you plug a 0 in for X, that is the place where we didn't sell anything and we lost money. If you plug a 0 in for Y, it's the break-even point. After that, we start making money. Okay, that's it for today, guys. We'll catch you next time.